Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we review area and Pythagoras. So you probably know by now Pythagoras involves right-angled triangles like this one here. So if the right angle is here, know that the side opposite the right angle, facing the right angle, is called the hypotenuse, and it is the longest side of the right-angled triangle, just as it was when we did trigonometry. And we usually call this hypotenuse C, and the shorter sides A and B. Of course, Pythagoras' theorem is that A squared plus B squared equals C squared. So if you know two sides of a right-angled triangle, you can easily find the third. So for example, in this triangle down the bottom, we have the two shorter sides and we want to find the hypotenuse. So rather than substituting everything into this equation and then rearranging, we can jump straight to this formula that will tell us the side length. So if you're finding the hypotenuse, it's just the square root of shorter side squared plus shorter side squared. So in this case, the hypotenuse is x. So it will be the square root of 6 squared plus 8 squared, and you can put that on your calculator if you need to, and the answer you get is 10, and of course we're in centimeters. So x in this triangle is 10 centimeters long. Let's look at an example where we're finding the shorter side. So let's look at this triangle on the bottom right. So now we're finding y. Now y is touching the right angle, so it's one of the shorter sides. In this case, we know the hypotenuse. So we can use a similar formula to what we just used, but this time it's going to be hypotenuse squared minus shorter side squared. So please note the difference. You add when you're finding the longest side, the hypotenuse, and you subtract when you're finding a shorter side. So unlike the previous example, we won't get a whole number answer here. So 18 squared minus 10 squared is 224. So y is the square root of 224. So that's the exact form. That's exactly what the length is. Or if you're asked to like 2 decimal places, it's 14.97. So that's rounded to 2 decimal places. So in both cases, we sort of jumped straight to the answer here and here rather than by substituting into our formula. And you can almost always do that. There's just one exception to that rule, and that's when you're finding two sides at once. I'm now going to show you an example of that. Please pause and copy this down if you need. So let's look at this right-angled triangle here. So I know the hypotenuse is 24 centimeters, but I don't know either of the shorter sides. But I know that this triangle is isosceles. It has two sides equal. So I can actually use Pythagoras to find the length of the two shorter sides. So I'm going to call them x. So, because I'm finding more than one side, I can't just jump straight to the formula. I can't use square root of, longer side squared minus shorter side squared. If I tried to do this, I'd be here all day and I wouldn't get anywhere. Instead, what we're going to do is take our formula a squared plus b squared equals c squared, and we're going to substitute into that. So A and B are the shorter sides and they're both equal to x. So I'm going to replace A and B with x. And of course C is 24. So I'm going to replace C with 24. Now I can solve this equation because I've only got one variable x. X squared plus x squared is 2x squared. And 24 squared is 576. So I want to get x by itself. So remember, order of operations means I square the thing and then times by 2. So when I'm solving, I must undo the timesing by 2 first. You do things in the opposite order to BODMAS. Because timesing by 2 is the last thing I did to x, it's the first thing I undo. So 2x squared divided by 2 is x squared. And the way I undo squaring is, of course, I square root both sides. So square root of x squared and then square root of 288. Once again, that's the exact form, and to 2 decimal places, I think it's about 16.97 centimeters is the rounded answer. So make sure you do things in the correct order because, of course, if you don't, you will get the wrong answer. So we've gone through Pythagoras. Pythagoras is really helpful when we're finding area. So let's look at an example where Pythagoras can help us find the area of something. So let's say I wanted to find the area of this triangle below. So I know all its 3 sides, but right now that's not enough information to find its area. Remember, the formula for area of triangle is base times height over 2. But whenever we have a h in measurement, whether it be area, volume, surface area, it's perpendicular height. I don't yet know the perpendicular height of this triangle, so I can't find its area. But Pythagoras will enable me to find the perpendicular height of this triangle. Now note, this triangle is not right-angled because 10 squared plus 13 squared clearly doesn't equal 13 squared. Pythagoras' theorem doesn't hold, so this triangle is not right-angled. So what I'm going to have to do is divide it into 2 congruent right-angled triangles. So I can do that as long as the triangle's isosceles or equilateral. You can only divide it into 2 congruent right-angled triangles if it's isosceles or equilateral. This one's isosceles because it has 2 equal sides. So I want to find this side here, which I call H. Now, because the 2 right-angled triangles are isosceles, this side here, I know it'll just be half of 10, which is 5. So I can find H easily. H is a shorter side, so I must subtract. It's hypotenuse squared minus shorter side squared, and that, of course, equals 12. So the area of this triangle I can now find. The area is the base times the perpendicular height, which I just found, divided by 2. And the answer is 60. Because no units were given, I just write units squared. So I was able to find the area by using Pythagoras. Before I used Pythagoras, I didn't know the perpendicular height. So let's look at another example where Pythagoras can aid us to find the area of something. Please pause and copy this down if you need. So let's say I wanted to find the area of this shape here. It is a trapezium. Because this angle and this angle are right angles and they're co-interior, I must have a pair of parallel sides. So the area of a trapezium is perpendicular height. Remember, H always means perpendicular height over 2 times the sum of the 2 parallel sides. A and B are the 2 parallel sides. Well, in this case, I know the 2 parallel sides, but I don't have the perpendicular height. So that's where Pythagoras can be useful. I can't find the area until I know the perpendicular height. So obviously it'll be the same as this height here. So the perpendicular height, I can form a right-angled triangle and use Pythagoras. So if it's 50 from here to here and 26 from here to here, this side here must be 24 meters from there to there, because of course 26 plus 24 is 50. So once again, I'm finding a shorter side. So H, the perpendicular height, I need to minus. It is the square root of longer side squared minus shorter side squared. And I get the answer here of 7 meters. Now that I have the perpendicular height, I can find the area of the trapezium. Perpendicular height divided by 2 times the sum of the 2 parallel sides. And of course, you can use your calculator if you need to. The answer I get is 266 meters squared. Once again, we would not have been able to find the area had it not been for Pythagoras. So let's look at more examples of finding area. Of course, we don't always need Pythagoras to perform area calculations. We're going to look at a couple of composite shapes. So that's one or more shapes stuck together. So let's look at the first example. So what we have a semicircle plus a rectangle. So to find the area, we just find the area of the rectangle, area of the semicircle, and add them together. So of course, this semicircle has a diameter of 20 centimeters. So that means its radius, half of that, will be 10 centimeters. So of course, the rectangle is 20 by 25 centimeters. So the total area of this shape is 20 times 25. That's for the rectangle. Now remember, the formula for the area of a circle is pi r squared. So in this case, it's pi times 10 squared. That would be the formula for a full circle with radius of 10. But of course, in this case, we need to divide by 2 because it's only half a circle. So if we put that on our calculator to 2 decimal places, we get about 657.08, and of course it's in centimeters squared, okay? So that was a case where we added two shapes together. If we look at the one on the right, let's say I wanted to find the area shaded blue. Well, this is a parallelogram with a circle cut out of it. So I need to do similar to what I did in the last example, but this time I subtract. So the area of the parallelogram is just base times perpendicular height, which is, of course, 700. Now, the area of the circle, the diameter is 10, but the radius is 5. So the area is pi times radius squared. Now, if you put pi times 5 squared on your calculator, you get about 78.53. I don't want to round that, though, and subtract from 700, because then my area would be slightly inaccurate. What I want to put on my calculator is 700 minus pi times 5 squared to be as accurate as possible. And the answer I get, again to 2 decimal places, about 621.46. This time I'm in meters squared. So area is pretty easy. I just want to spend a minute or so going through converting square units. Once again, please pause and copy this down if you need. 10. So on your screen is a chart for converting units of length. For example, if you want to go from kilometers to meters, you times by 1,000. You probably already knew that. So the rule of thumb is if you want to go from a larger unit to a smaller unit, you times, because there are more of the smaller unit. There are more meters than there are kilometers. So if you want to go the other way, if you want to go from a smaller unit like millimeters to a larger unit, you divide, because there are less of the larger unit, okay? You probably already know this, but what people, even in year 10, still forget is that if you're converting square units, you need to square everything. So let's say I want to go from kilometers squared to meters squared, I have to square the conversion factor. All of these get squared. So 1 kilometer squared is actually 1,000 squared, which is 1 million meters squared. So the reason for that, if you have a kilometer squared, a kilometer by a kilometer, well, a kilometer is 1,000 meters. So this is 1,000 meters by 1,000 meters. So obviously 1,000 times 1,000 is 1,000,000, or 10 to the power of 6 meters squared. That's just a quick example as to why you need to square the conversion factor. If I have something like 7,200 millimeters squared and I want to convert to centimeters squared, I need to take 7,200 and divide by 10 squared, which is dividing by 100. And that's actually 72 square centimeters. So there's one thing in square units that's not on this chart, and that is hectares. 1 hectare is 100 meters by 100 meters. So of course 100 by 100 gives 10,000 meters squared. So 1 hectare is 10,000 meters squared. But of course, 100 meters is 0.1 of a kilometer, 1/10 of a kilometer. So 1 hectare is also 0.1 by 0.1, which is 0.01 square kilometers. So there are actually 100 hectares in a square kilometre. All right, sorry for the long video. Hope you've enjoyed it. This has been the luckiest maths teacher in the world. Have a great day.